Good morning, students. So, as you know, we have a little interaction with you. I am a new face to you. Already 3 teachers are teaching to you. So, I have told some things, some contents in the bridge course, and also recently in the last week I have taken one online class also. So basically it's also a new thing for me and I am also new for you. So myself, Mrs. Simran Bhaboji. So I am the new one to teach you physics. Okay, so physics classes have running from so far. So you have studied some various chapters. So today I am starting the 7th chapter. The 7th chapter, whose name is the system of particles and rotational motion. Okay, so means before starting the chapter, as you know, the heading itself indicates system of particles and rotational motion. Means there are 2 parts. System of particles is one part, rotational motion is one part. So before switching on to the actual syllabus, the actual part of this chapter, we will discuss about some basic things, because in any subject, if you know the basic very well, if your base is very well, you can build a strong building on that, isn't it? So let's learn some basic things first. Okay, so means about to tell you what is science, about to tell you what is physics, all these things you may have studied now, because already 3 members have told this regularly, often and often. Okay, so what I felt is, so most of you are feeling physics as a tough subject, a difficult subject. No, it's not actually, because if you understand the concept first before going to do any derivation, before going to solve any problem, or before going to read anything in physics, if you understand that concept very well, I'm sure you will love the subject, isn't it? Means whenever a teacher is delivering a lecture or he is explaining any concept, if you start imagining the things, or if you start visualizing the things in your mind, the whole picture of that concept will be clear to you. Understood? So if you do this, it will be a wonderful subject for you, isn't it? So don't worry much, don't think much, just go simply by visualizing the things, by imagining the things, isn't it? So as you know, we are discussing the 7th chapter, system of particles and rotational motion. Okay, so previously you have studied motion in a plane, motion in a laws of motions. Means some chapters in mechanics you have studied, isn't it? About motion you have studied. Means you are familiar to mechanics, isn't it? So many chapters you have studied under mechanics before this. Means you are studying about velocity over there, displacement, distance, speed, acceleration, all those things you studied in mechanics. Mechanics is nothing but what? It is a branch of physics which deals with motion. Means the word motion, related to this word motion, whatever you learn, that comes under mechanics, isn't it? So in mechanics, while understanding or while discussing any concept, you have considered that object as a point object. Means if any object is moving, you have considered it as a single particle, or you have considered it as a point. Means if any object is moving, you will consider it like this. This object is moving and it is doing displacement, it is changing its position from one place to another place, so hence it is doing displacement, so hence it is having a displacement, it will be having velocity, hence it is having a velocity, it will be having acceleration. All those things you studied in mechanics. So what is my motto of telling is, in mechanics you have considered the object as a single particle, or I can say you have considered it as a point object, isn't it? You have considered it as a point object, means single particle. Okay, now you imagine a bottle of water is there, a bottle full of water is there. So in that bottle, how many particles of water are there? How many molecules of water are there? Number of particles are there. So that bottle full of water, you can call it as a group of so many particles, isn't it? Or also you consider any book is there. Any book is there. So in that book, number of single pages are there. Understood? Single page is different. A book is different. So that book, you can call it as a collection of or group of so many single pages. Like that, if instead of considering a single particle, if you consider the group of particles, or if you consider the collection of particles, that will give you the system of particle. Understood? Instead of considering a single particle or a point object, if you consider the group of objects or the collection of particles, you can say it as a system of particles. Understood? System of particles is nothing but what? If this is one object, in that so many number of particles are there, like this, so many number of particles are there. Understood? So this whole object we can call it as a system of particle. You can call it as a system of particle. Don't go much away. Your body itself, you consider your body is a system of what? Number of cells are there in your body, isn't it? In biology you may have studied that cells are nothing but what? Building blocks of your body, isn't it? So your body is a system of number of cells. Your body is a system of number of cells. That cells are nothing but what? Particles. Understood? So group of number of particles or collection of number of particles is nothing but what? System of particle. Okay, so now you try to give some examples for system of particles. We already told a bottle full of water. Your body is a system of particle. A book is a system of number of pages. Or you consider anything. Your class itself is a system of various students. Understood? Your college is a system of various people. Like that, a group or collection of particles is called as what? System of particles. This whole body we can call it as a system of particles, which will contain the end number of particles. Understood? So this is about system of particles. So whenever you observe the number of systems in your surrounding or in the nature, you may see various things. Okay, what we did, a bottle we considered, in that we had water. In book we had pages. In our body we had cells. In the atmosphere we have number of air particles, isn't it? So whenever you observe the different system of particles in your surrounding, they are existing in different states. Understood? The substances or the matter exist in different state. That may be solid, that may be liquid, that may be gas. So you know very well about the difference between solids, liquids and gases. In your previous classes or in your school time only you have studied the difference between solids, liquids and gases. Let just study about the properties of solids, so that we can switch on to the properties of liquids and gases also. So when you think of solids, how solids will be? How the solids will be? Now this duster is also one solid. This chalk is also one solid. How its nature is, you consider. How its nature is, you just observe. How it is having weight. Is it heavy a little bit? Yes. So it is having what? Size it is having. Understood? Weight it is having, and it is somewhat in this shape. It is some different shape. Okay, so it is having some shape also. So the first thing we can say that solid is having a definite size and shape. Solid is having what? Definite size and shape. Understood? Okay, so when you think about size and shape, is it there for liquids and gases also? Yes. What happens for liquids? And what happens for gases? Yes, liquids are also having size. If you have a bottle of water, it is also having some weight. Understood? So it is also having size. Is it having shape? No. So the liquid and the gases don't have any shape. So we can say solids are having definite size and shape, but liquids are not having definite, means liquids are having definite size but not shape, and gases are not having definite size, are not having definite shape. Understood? So next we can say that in the solids, if you consider any solid, the molecules are tightly packed, isn't it? Like this, the molecules are tightly packed without any single gap. Molecules are tightly packed, but here in the liquids, no, they are loosely packed. Means, see here, you can see the gaps here between the molecules. You can see the gaps, but in gases, the molecules are far away from each other. If in this room, if you leave any gas like oxygen, carbon dioxide, helium, any gas if you remove, it will cover the whole space available. So the molecules are far away from each other with much space between them. Understood? So this is how the patterns are arranged. Next means this is basic thing, just I am discussing. Okay. Next is, see, I told you in this the molecules are tightly packed, but if they are tightly packed, there is no any gap between the molecules. Now means intermolecular space. With that gap between the molecules, what we call intermolecular space. So here in the solids we don't have any intermolecular space, but here we are having intermolecular space. Here we don't have, means here a little bit intermolecular space, here much large intermolecular space. So here next, here why the particles are tightly packed or why the molecules are tightly packed? Because between any two particles, between any two molecules, there is a force, there is a attracting force. Understood? So the interaction force, the force of attraction between these particles is very high. The force of attraction between these particles is little bit. Here we don't have any force of attraction between the particles. Understood? Means these are some properties of the solids. Okay, so when you think of solids in detail, when you distribute the solids in some types, you will get two types over there. The first type is rigid bodies, okay, and the second type is non-rigid bodies. Means if you divide the solids in some types depending on their properties, you will get rigid bodies and non-rigid bodies. Okay, so what are these rigid and non-rigid bodies? Okay, don't leave rigid, non-rigid, solid, liquid, leave anything. Just now consider simple examples. Okay, first you consider a stone. Which shape will be stone will be having? Any shape. Okay, this is a stone. Okay, consider a piece of wood. Consider a plastic ball, and consider one more any elastic material, means consider a sponge ball. Okay, so leave about rigid, non-rigid, everything. Just now go on imagining the things. So this is one stone. How stone will be? Very tough, hard it will be, isn't it? So what happens if you apply the force on that? What happens? Means this is not stone, but just consider a stone, a big stone, and having let's consider this as a stone for right now. Okay, so this is stone. So like this, if I apply the force on stone, what happens? Obviously you will get a pain in your hands, but anything happens to that stone. If it is a big stone and I am applying the force on it, nothing change is visible there. No any change is visible in that stone, isn't it? So if you apply the force on that stone, no doubt if you apply the force like this, it will move. But what I am saying is, keeping the stone at rest, if you are applying the force on that, you will get nothing. You will means any change is not visible over there. So what we can say is here, no any change. No any change. Okay. The same thing you do with the wood also. Yes, it is a piece of wood. Okay. So this also I am applying the force. I am applying the maximum force I can apply. Okay. So here also no any change. So here also no any change. Understood? So now consider the plastic ball. You may be having a plastic ball. So if you, it means ball will be like this, round ball will be this. So if you apply the force on that ball, plastic ball, what happens? Yes, it crushes for a bit. It crushes, isn't it? Means there is some change. What's that change? Some change in size and shape of that plastic ball, isn't it? So if you apply the force on that ball, initially the ball will be like this properly. If you apply the force by all the sides on that with your hand only, so it will get some, means if it is round, it will get like this, means some changes it will get. Okay. So on the sponge ball also, if you apply the force, initially it is this much bigger. If you apply the force, it becomes this much only. Understood? So what I am doing with the different things, we are just applying the force. Okay. Now on this plastic ball, you have applied the force. You have applied like this. If you have applied, and remove your hand now. Remove your hand. And what happened? The same thing. After applying the force, whatever the shape you have got, the same will be there even if you remove your hands. But on the sponge ball, if you apply the force and you remove it, it will come back again like this, isn't it? But this phenomena will not happen in the case of stone and wood. Understood? Because they are not allowing the change in size and shape initially only. Whenever you apply the force, they are not allowing the size and shape to change. But here the changes are occurring. But if you are removing that forces, some things cannot come back to their original size and shape, but some things are coming back original to their size and shape. So what the things you can observe in all these examples? All these examples we can observe that we are applying some force on every object, different kinds of object we are applying the force. Some things are responding, some things are not responding. Understood? So the force you applied on every body is deforming force. Deforming force. So here deforming force will not result into any change. Deforming force will not result into any change. Deforming force is showing some changes but no any reverse process. Here deforming forces are showing the changes also, and in turn after removing the deforming forces, the body is getting its original size and shape. So with respect to these two types of solids, rigid objects and non-rigid objects, we can list this stone and wood in this category and these two in this category. Understood? By observing all these examples, can you frame the definition for rigid bodies now? Can you frame the definitions? Yes. Means if I am telling the stone and wood are the rigid bodies, so how their nature is? They are not showing any change in their size and shape by applying the forces. On application of forces, rigid bodies are not showing any size and shape. Hence, we can frame the definition of rigid bodies as the bodies which will not show any change in size and shape after the application of forces are called as what? Rigid bodies. Understood? The bodies which are not showing any change in size and shape after the application of forces are called as rigid bodies, and in reverse, the bodies which are showing the change in size and shape after the application of forces are called as non-rigid. So non-rigid also we can divide in two types, plastic and elastic. So the things which will get changed after the deforming forces but cannot come back to their original size and shape are plastic objects, and the things after the removing deforming forces which are coming back to their original size and shape are called as elastic objects. But here we are more concerned to study about rigid bodies. Understood? This is about what? Rigid bodies. So now you have understood what are the rigid bodies and how it will be. So if you go in detail with respect to rigid bodies, now just consider this is one rigid body. So if you apply the force on this rigid body, this will not showing any change in size and shape. Okay, but in this rigid body you are having number of particles. As I told you, in any system we are having n number of particles. So in this rigid body you consider just 4 particles. I am considering much number of particles are there. Okay, if you focus at these 4 particles and just you consider these are the 2 pairs of the particles. Okay, these are the 2 pairs of the particles and these are the 2 pairs of the particles. Okay, so if you apply the force on this rigid body, if you body starts moving, if you are applying the force like this, if this body is this, if this is a rigid body and in this we are having the 4 particles, and if I apply the force like this up and down, it will not get any change. But if I am applying the force like this, means I am applying the force in this direction, so this is moving. Okay, so with the body, all the particles in this rigid body are also moving in that direction. So while moving, what happens? The distance between this pair of particles and the distance between this pair of particles means if the body is moving, this distance is also same. This keeps same only. This is also moving like this. These 2 particles also moving like this, keeping the same distance. Understood? If you consider these 2 particles and the object is moving, so these 2 particles are also moving, keeping the same distance, or otherwise you consider these 2 particles as the pair. So if this body is moving, these 2 are also moving by keeping the same distance. So what I am telling is one more additional point about the rigid body. Rigid body is whenever the force is applied on the rigid body and whenever that rigid body is moving, the distance between all pairs of the particles remains same throughout the motion. The distance between all pairs of the particles remains same throughout the motion. So this is how the rigid bodies are moving. So the rigid bodies are moving in 2 kinds, means types of motions of rigid body. One is translational motion, means if you apply the force on the rigid body, it will show us the 2 kinds of motions. The first one is translational motion and the second one is rotational motion. Means whenever you apply the force on rigid bodies, it may show translational motion, it may show rotational motion, or sometimes both. Okay, so what is the translation motion of rigid body? So now you consider like this, we are having a plane here. Okay, we are having a plane here, means some inclining plane we are having. Just consider that any body is falling from a hill. Okay, so it is coming back to the earth. Now this, consider this is one rigid body. This is one rigid body we are having. Okay, so if you apply the force here or if you leave it, it is moving like this. Means the rigid body is moving like this. Whenever this rigid body is moving, the body is moving parallel to this plane and all the particles inside that body, it may here, it may be here, it may be here, anything, all the particles inside that body are also moving parallel to that plane. Means in a straight line parallel to the given plane, the body, the system of particles and every particles of the system are moving parallel to the plane. That is called as what? Translational motion. The rigid body and all its particles are moving parallel to the plane in a straight line. That is what? Translational motion. And in this translational motion, the velocity Velocity, you have studied in mechanics. What is velocity? The rate of change of displacement with respect to time. Okay, the velocity of every particle is same, because if this is moving like this, if you consider one particle is here, one particle is here. So do you get any changes like this particle is moving fast and this particle is moving slow? No. Every particle of that rigid body are moving with the same velocity. Hence, in this translational motion, velocity is same. The velocity of every particle is same. So, when you consider about rotational motion, rotational means any rotational motion you consider. For example, fan you consider, a ceiling fan. Okay, what happens there? One axis will be there, one fixed axis will be there, and along that the wings are moving. All the three wings are moving along that fan, along that axis. So this axis is also a part of that system. If you consider fan as a whole system, that axis is also part of the system, and those wings like this, three wings you will be having like this, anything. So if that wings are moving like this, they are also part of the system. So we are having the particles on that axis also, and we are having the particles on the wings also. But here the particles which are present on that axis are at rest, are not moving, but whatever the particles are there in the wings, they are moving. Understood? So here what we can analyze here, that now you consider, so if this is one motion, this is one object, you just consider all those three wings as a single, and this is the object which is moving around this axis of rotation. So in this object we are having number of particles. So here one particle is there, and here one more particle is there. This particle is also rotating around this axis. This particle is also rotating around this axis. Now just consider, this particle is rotating like this, and this particle is rotating like this. This is particle number 1, P1 and P2. Okay, so when it is rotating like this, with respect to some time t, both are moving with respect to the some time t. Okay, so here we will get angular velocity. In the chapter circular motion you may have studied angular velocity, omega. Means if now this particle is at this position, after 1 second it comes here. Understood? Means in 1 second this particle has covered this much distance. Understood? Means this much distance that particle has covered in 1 second. So that is what? Displacement from this position to this position. Angular displacement. So here it is making an angle theta. That theta is what? Angular displacement. Theta is angular displacement, and this particle is showing some angular velocity, that is omega. What is relation between omega and theta? Omega is equal to theta divided by t. Omega is angular velocity, this is angular displacement. Like you are having v is equal to d by t in the linear motion or in the translational motion. This is velocity, this is displacement, time. Angular velocity, angular displacement, time, like that. Okay, so this is the particle which is showing this much of angle, and it is having the angular velocity. Okay, now this is also one particle, and it is somewhat near to the axis of rotation. This particle is somewhat away from the axis of rotation, and this is nearer. This is far, this is nearer. So in 1 second this particle also will cover the same distance, and it will also make the same angle. Angular velocity is same. So for all the particles traveling over there, angular velocity is same. Understood? So in this rotational motion we will get omega, the angular velocity is same for all the particles. Understood? But if you consider the linear velocity, means like this, if you consider the velocity here in the rotational motion, we will get the linear velocity v as r into omega. Understood? So this omega is same. Okay, r is what? the distance of the particle from the axis of rotation. So here for the particle P1 we are having the distance R1 which is large, and for the particle P2 we are having the distance R2 which is small than R1. Understood? So in the rotational motion, linear velocity is not same, is different, because we are having the distances as different. Because if this is a whole system which is rotating around the axis of rotation, in that system we are having number of particles. So some particles may be nearer to the axis of rotation, some particles may be away from the axis of rotation. So depending on the distance of that particle from the axis of rotation, we are deciding the linear velocity. That's why linear velocity is not same in the rotational motion, but angular velocity is same in the rotational motion, because every particle is covering the same distance. If this is one axis of rotation and around this the whole system is moving, means if one particle is moving here and one particle is moving here, they are covering the same distance. Understood? Hence the angular velocity is same in the rotational motion, and linear velocity is same in the translational motion. This is how the rigid body shows its motion. The motion of rigid body has two types, means the rigid body will undergo motion in two kinds, that is translational motion and rotational motion, and this is about both of the types. Okay, so now we have understood what is the rigid body, means the definition of rigid body we have understood. What is that? The body which will not show any change in its size and shape after the application of forces, and also the distance between all pairs of the particles remains same during the motion. This is called rigid body. Means how we can define rigid body? The body which is not showing any change in size and shape after the application of forces. This is one part, and the distance between every pair of particles remains same in the motion. Two parts. You can write the definition of rigid body like this. Means rigid body is the one which will not show any change in size and shape after the application of force, and the distance between every particles remains same during the motion. That is rigid body, and it undergoes these two kinds of motions. Okay, so now in this chapter, system of particles and rotational motion, as I told you, we are having the two parts, system of particles, rotational motion. So now we have clearly understood what is the system of particle, and we have considered the rigid body as the system of particles, and we have studied about this in detail. Okay, now switching on to the next concept, which is very important in this chapter and which is very essential to know about, is center of mass. Center of mass. Means what is center of mass? What is CM? CM is Chief Minister, ma'am. No, center of mass in the system of particles. Means in your body only you consider, because I have given you the example of system of particles. This is a system of particles. Understood? Which is the center of this? Means the thing which controls all the activities of your body. Is it brain? Yes, of course, brain. If you don't have brain, you can't live. No. Brain dead people also will live. Heart. If it stop beating, you can't be alive. Isn't it? Hence, I can consider this as the center of mass of this body. Means which controls the body throughout is the heart. Like that, if you consider any solid body, if you consider any rigid body, because we are talking about a rigid body only here. So, in rigid body, the point where the whole mass of the body is assumed to be concentrated. Means if you consider this as one rigid body, so at center of mass, means it is at the center obviously. So at the center we are having a point like this. Okay, so this is the point where the whole mass of the body is assumed to be concentrated. Hence it is called as what? C1. What is center of mass? The point in the object where the whole mass of the body is assumed to be concentrated is called as what? Center of mass. This is the meaning of center of mass. And now then why it is so important that we have to study this in detail? Why we have to study about center of mass, isn't it? Because this center of mass will decide so many actions or properties of the body. For example, you consider now, this is one body as I told you, and this is the center of mass. Now what we'll do, let apply some force on this body. Okay, let apply some force like this. Different kind of force. Means different types of force, not different types. The same magnitude of the force will be same, but the applying direction will be different. I hope you know the game between magnitude and direction, isn't it? Magnitude and direction, I hope they are familiar to you. Okay, means on this object I am applying the force with same magnitude in different direction. So here I am applying one force, here also I am applying one force, and let apply some force here also. Okay, now see how the action of that every force act on this body. If you apply the force like this body will move like this. Means by the application of this force 1, this body will show linear motion in this direction. Okay, means this is one object and its center of mass is here. I am applying the force exactly here, and that force, the line of force, the action of force is passing towards that is crossing from the center of mass, that is passing from the center of mass. So that force will cause this body to show a linear motion in this direction. Okay, so now consider this second force. So what's the effect of this second force? If you apply the force like this force, the action of force, or I can say the line of force, is also passing through the center of mass, and because of that second force, the body is showing the linear motion like this. Okay, so now third force, the third force whose line of action is not passing from the center of mass. So what's the effect of this force, third force? So now this is the body. First force I applied, it is going like that, linear motion. Second force applied, it is going like that, linear motion. Now I am applying the force here. Now see here, if slightly I am doing like this, it's moving, but its motion is somewhat different. It's not linear motion. See, if I apply the force like this, it will go like this. It is showing what? Rotational motion. Understood? The force which I am applying here and here are causing linear motion, but whatever the force I applied here is causing rotational motion. Means the force whose line of action is passing through the center of mass. The force whose line of action is passing through the center of mass are causing the linear motion in that body. And the force which is not passing through the center of mass are causing rotational motion of the body, isn't it? Hence, this center of mass has that much importance. Understood? The heading itself indicates rotational motion. So here we are applying various forces, and various forces are giving us the various outcomes also. This which is passing through CM is linear motion. This which is passing through CM is also linear motion. But this, or also you can consider the fourth, which is not passing through the linear center of mass, will also rotate the body. That's why it's very important to study about center of mass. Understood? This is about what is center of mass and what is the importance of center of mass. Okay, so this was some introduction about the 7th chapter, system of particles and rotational motion. So we have studied in this chapter in today's class we have studied the meaning of system of particles, some examples for system of particles, the properties of solids, and in that types, rigid bodies, non-rigid bodies, and we are discussing in detail about the rigid body, and we have switched to center of mass. Okay, after this we are having one derivation on center of mass that we will discuss in next class. Okay, if you have any doubts about today's class, you can ask me through the message or through any way. Okay, thank you.